So in this video we're going to talk about two-way frequency tables. And so to get started, I just wanted to go back and mention a frequency table is literally just a table that counts up the frequencies, how frequent something is. It's like the count. So like here's the count for how many people picked mac and cheese and how many people picked sandwich and so on. This only has one variable, the lunch choices. But if we have two variables, we call it a two-way table. Literally just because it goes two ways. In this case, we have whether or not they play an instrument, and then whether or not they play a team sport. And so it counts up the frequencies of the different combinations. So there are 8 people who play an instrument and play a sport. 2 people play a sport but don't play an instrument, and so on. And then we can total everything up in the margins here, and then the overall total is 20 in this case. So 20 people did this survey, and these are the results. So let me see here. Just a little vocab. First of all, two-way frequency tables are helpful for looking at the relationship between like two categories. In this case, it would be like the grade level and whether they like dogs or cats. You add up each row and you add up each column to get these totals. And then, just so you know, the entries that are in the actual body of the table, like the entries that are joined between two things, we call those joint frequencies because they're literally joined between like freshmen and dogs, sophomores and dogs. Like these are joined in between two things, and so these right here are all the joint frequencies. Whatever's in the margins, these totals, we call them marginal frequencies because they're in the margins. So these are marginal frequencies and these are marginal frequencies, and we usually don't include the total, but. So there we go, that's just a little vocab for you. And then, what we usually do with tables like this is we calculate different percentages. So if I really wanted to, I could calculate like out of everybody who did this survey, like out of all 50 people, how many of them were freshmen who like dogs? And so that would be those 12 people out of 50, which, let's see, that is. So 12 divided by 50 is 0.24, which would be 24%. So this right here is 24% out of everybody. And we could do that with each of these other joint frequencies as well. We could divide them by 50 and see what you get. But what if I want to break it down, like break down the freshmen and break down the sophomores? So like out of the freshmen, how many preferred dogs? That's a different question than what I just asked. I'm saying if I just look at the freshmen, how many of them prefer dogs? And in that case, we're not going to divide it by the 50. We're just going to do 12 out of 25, which would be 0.48, almost 50%. So it's 48%. So if 48% prefer dogs, that means 52% of them prefer cats because they would have to add up to 100%. I could even do 25 out of 25, which would be 100%. And then if we look at the sophomores, 16 out of 25 prefer dogs. 16 out of 25 is 64%, or 0.64. And then 9 out of 25 would be 36%. And together those would add up to 100%. So that kind of gives you an idea of how you can calculate what's called a conditional frequency, or sometimes a relative frequency. It's what you get when you take a joint frequency and divide it by a marginal frequency. Basically, when you take a percentage out of a row or a percentage out of a column, it's based on the condition that like you are a freshman, or based on the condition that you are a sophomore. It's also called a relative frequency because it's relative to whether you're a freshman or whether you're a sophomore. So I was doing conditional frequencies based on the rows. You could also do it based on the columns. So rather than saying, what's the probability that you like dogs given that you're a freshman, why don't we flip that around? Given that you like dogs, what's the probability that you're a freshman? It's still that same 12, but it's this case it's out of the 28 people who picked dogs. So in that case, 12 out of 28 would be about 0.43 or about 43%. And then if we did 16 out of the 28, we would get about, let's see if that actually worked out, yeah. We would get about 57%. That's going to be different. Out of the people who picked cats, 13 out of 22 were freshmen, so that's about 59%, and 9 out of 22 were sophomores, which is about 41%. Which tells me that out of the people who liked cats, like more of them were freshmen, and out of the people who liked dogs, more of them were sophomores, and that kind of thing. All right, and so again, those are called relative frequencies or conditional frequencies when you take a joint frequency and divide it by a marginal one. You also could calculate a few other things as well. Just for example, like let's say I just want to know out of everybody how many picked dogs. In that case, I would take this marginal frequency of all 28 people who picked dogs and divide it by the 50, and we could do that as well. We could do the same for like freshmen and sophomores, which would be 50% and 50%.